Okay, so if we have a limit of the form, the limit as x approaches a of f of x over g of x. And let's say that becomes 0 over 0 or infinity over infinity. It doesn't equal 0 over 0 or infinity over infinity, but like each numerator and denominator goes to infinity, or each numerator and denominator goes to infinity over infinity. Then we say it's an indeterminate form. L'Hopital's rule states if the limit as x approaches a of f of x is equal to the limit as x approaches a of g of x, which equals 0 or infinity. So both of them are 0 or both of them are infinity. And by the way, let's say one of them was like negative infinity. You could just factor out a negative and still use L'Hopital's rule. So if you can say separately that your numerator and denominator both go to infinity or 0, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x divided by g prime of x. So this is L'Hopital's rule. Notice that we're not using the quotient rule. I'm not taking the derivative of the entire fraction. What I'm doing is I'm taking the derivative of the numerator and I'm taking the derivative of the denominator. And you'll notice that we have to start with this part here, which is showing that the numerator and denominator separately both go to 0 or both go to infinity, meaning you're not like, right, this is kind of like layman's terms, but what you need to do is use proper limit notation and show that the limit of the numerator goes to 0, the limit of the denominator goes to 0. So then I can use L'Hopital's rule and take the derivative of the numerator and denominator and calculate that limit. So what do I mean by that? Like, how is that helpful? Looking at number 14, limit as x approaches 4. Now, we have solved this exact problem before using conjugates, but I'm not going to use a conjugate for this one. I am going to use L'Hopital's rule. So L'Hopital's rule would be this. Okay, if I plug in 4 in my numerator, I get 0. If I plug in 4 into my denominator, I get 0. So again, you have to show your limits for numerator and denominator separately. They both go to 0. Then that means that this limit as x approaches 4 of root x minus 2 over 4 minus x, is the limit as x approaches 4 of, and then what we can do is take the derivative of my numerator and divide it by the derivative of my denominator. So the derivative of my numerator, so x to the 1/2 would be 1/2 x to the negative 1/2. And the derivative of my denominator, 4 minus x, is negative 1. Okay, so now if I were to plug in 4, I don't get 0 over 0. I don't get an indeterminate form. I get an actual number. So let's go ahead and simplify this. 1/2 divided by negative 1 is negative 1/2. And then x to the negative 1/2 power would be over the square root of x, but I'm plugging in 4. Okay, so I'm just rewriting it, and because I'm plugging in the actual number, I'm allowed to stop writing limit. And so this becomes negative 1 over 2 times 2, which is 4. So it's just another way of solving limits. Sometimes you would need to use L'Hopital's rule, like in number 15, you're going to see we need to use L'Hopital's rule. And sometimes you don't. So you will have the option to either use L'Hopital's rule or not. But just remember, for L'Hopital's rule, you do have to show the limit separately, and they both need to go to 0 or infinity. As soon as you can plug in the number, you can plug in the number and then just solve. So for number 15, I have the limit as x approaches 0 of cosine squared minus 1 over 3x squared. So if I plug in 0, right, I can already see I'm going to get 0 in my numerator and denominator, but I have to write it out. So the cosine squared of 0 is 1. 1 minus 1 is equal to 0. And then same thing with my denominator. If I plug in 0, I get 0. So I showed them separately. So now I can use L'Hopital's rule, which is to take the derivative of my numerator and divide it by the derivative of my denominator. So the derivative of cosine squared, so the derivative of cosine is, because you have to use chain rule, right? Derivative of cosine is negative sine times the derivative of cosine something squared would be 2 times something to the first. And then the derivative of 3x squared is 6x. Okay, now try to plug in 0. What are you going to get? You're going to get 0 in my numerator, right? Because sine of 0 is also 0. And I'm going to get 0 in my denominator. So I was not able to plug in 0 and get a number. I got an indeterminate form. I got 0 divided by 0. So what does that mean? It means I'm going to use L'Hopital's rule again. So sometimes you have to use L'Hopital's rule more than once. No problem. You just, again, have to show separately your numerator and denominator both going to 0 or both going to infinity. And then you can use L'Hopital's rule. So the derivative of negative sine times 2 cosine. So that's negative 2. And then the derivative of sine is cosine times cosine. And then you have to do the derivative of cosine times negative 2 sine. Here, you know what? This might be too confusing. Let me explain. I am using product rule on negative 2 sine cosine. So the derivative of negative 2 sine cosine is going to be f prime g times g prime f. So the derivative of negative 2 sine is negative 2 cosine, and then times g, which is cosine, plus the derivative of cosine, which is negative sine, times negative 2 cosine. I'm sorry, negative 2 sine, divided by derivative of 6x, which is 6. Okay, now I can plug in 0 and see what I get. So if I plug in 0, cosine of 0 is 1. Cosine of 0 is 1. Sine of 0 is 0, so that part goes away. So I get negative 1/3. So in this case, I did have to use some derivative rules. I had to use chain rule, right? Chain. And then here, this is a product, so I had to use product rule. And if you were confused by me using product rule, I know I went over it quickly. Just go back and rewatch or do it yourself. Use the product rule and see that you get the same answer. Okay. So L'Hopital's rule. Show your numerator and denominator separately. Then you can take the derivative of your numerator divided by the derivative of your denominator. You are not using quotient rule. It's its own thing. We're not taking the derivative of the whole thing. We're just taking the derivative of the numerator and denominator separately in order to apply L'Hopital's rule.